What is a catalyst optimizer? So this is one of the favorite interview questions. So if you are a highly experienced person, let's say you have 10 years experience, 15 years experience, this is definitely one of the questions that you can expect. Okay, so very important concept. So what exactly is a catalyst optimizer, right? So at Catalyst is Spark's SQL internal optimization framework that converts an SQL data frame queries into highly efficient execution plans, right? Using rule based and cost optimization, right? So this is the important thing. So highly efficient execution plans. Okay. So this is basically the definition. So now let's understand this with a simple example, right? We need to understand this a little bit more in detail. So let's take an example. Let's suppose that you are working in an Amazon, right? And you deal with a lot of data there, right? So let's say you have a table where they are storing details of the customer, what they have purchased, what is the amount that has been spent, what is the region, all the other demographics, names, and everything. So there could be like 10, 20 columns, right? Now, what we are interested in is we are trying to understand the revenue generated in each of the country or a particular country. So first, as for example, you have this customer ID, right? You have the orders, right? So the amount that is being spent on the order and the country where this is spent. So what I'm trying to understand here is like Amazon is in many countries, right, all over the world. So let's say we have data in India, we have data US, Europe, and so many other countries. So let's say we have, for simplicity, we have around 30 countries, and each country has probably 10 million records. Okay, 10 million records. So now what we want to do is we want to understand how much of money or how much of money is being made in India across all customers. Okay. So basically what we are trying to do is we are trying to get how much of money is being made in India. Okay. So that is the requirement that we are trying to accomplish. Okay. Now, what we could do here is like, again, there are multiple ways how you can achieve it, but for simplicity, let's say somebody, a new engineer has come and this person has written a code, something like this, where, okay, hey, I'm going to do first, there are like 10 countries, right? So I'm going to do sum of amount group by country. Okay. And once this operation is done, what I'm going to do is I'm going to write a where clause to actually get only the details related to India. Now, this will give me the data that I require. But there is a problem with this approach, right? So, what you are doing is like you are actually putting an operation on 10 countries, which, and then you are basically filtering out. We don't need the operation to be done on the 10 countries, right? We don't want to know the revenue generated for all the 10 countries. We are only interested in knowing the revenue that is generated in one country, right? Which is basically the our final output here we are receiving. But why do we have to do the sum for all the countries? So instead, what we could do is, second approach, what we could do is we could first basically do a filter where we say, hey, first, let me just get only the data that is required, right? So I only want the data related to India, and then I will do a sum, okay? Sum of the revenue. Sorry, sum of the amount. This way, what I am avoiding here is I'm avoiding doing an aggregation on 9 other countries. Okay, so I'm only doing aggregation on one country which is required for me. Okay, so these are the two approaches, right? Now, obviously, the second approach saves us time, right? This is a better approach than the first approach. So imagine that this new engineer has actually put this approach. Now, will Spark execute this as it is, right? So now this is where the Catalyst Optimizer comes into the picture. So the Catalyst Optimizer will scan the code. It will basically create a logical plan out of this. Okay, so it is not going to execute as it is. It is going to create a logical plan out of this. Now, logical plan, the optimized logical plan it will create. So once this optimized logical plan is created, it will create a physical plan, and then this physical plan is what gets executed. Okay, now this plan may be different than what the engineer would have written, right? So in the engineer would have written like, okay, first I'm going to do an aggregate, and then I'm going to do a filter, right? But this plan might say, hey, first we need to do a filter and then we need to do aggregate. So this way, your performance will be improved, right? So that is the concept of catalyst optimizer. Catalyst optimizer does this, right? And in the definition, we have seen like, catalyst optimizer does this by using certain rules, blah, 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 right? So obviously there needs to be some rules for the catalyst optimizer to take some decisions, right? So there are certain things, okay, what catalyst optimizer does. Okay, so how does this optimizes the query? So there are certain rules that the catalyst optimizer uses. So some of them, like, it has something called as predicate pushed on. So what does predicate pushed on mean? So predicate pushed on basically tells you that we need to use the filter before it joins. So this is basically where before join. So if there is join and if there is a where clause that needs to be done, then what catalog optimizer says, like, first let's filter out all the records. First put the where clause so that we reduce the number of records that needs to go into the join, right? So that is one of the rule. And second is we have something called as column pruning. Okay, so imagine there are like 100 columns, but do we really need all the columns, right? Only the columns which are required, though only those columns will be read. Even if you have like 100 columns, if you're only using two columns, like in our example, we only need the amount column, we only need the country column. So even if we have like 100 columns, we don't need all the other columns. We only take the columns which is required. So those are the columns which we will take. Okay, join reordering. So there's another rule like join reordering. Like if you have a small table, this would be the smallest, and you have a big table. You always look at the small table first, right? That is one of the rules that the Catalyst optimizer uses. There is a broadcast join. Okay, so a broadcast join basically, like if you have a smaller table, instead of sending the table again and again, what we will do is we basically kind of share that table like a cache, right? So that is basically broadcast. So if the table length is like less than 10 MB, then broadcast join will take it. Then uh, projection push down. So basically avoid unused columns. So these are basically the rules that the Catalyst optimizer uses to kind of ensure that the right approach is being followed. Okay, so let's take an example. So we have the code here. Okay, so we have the code here written. So what we are trying to understand here is like we have the customer data. So this is a very, very small data. We just have four records of the same concept that we talked about. The customer data, we have the IDs, the names, and which country they belong to, the orders. Then there's another data frame called as orders, which is linked to the customer ID. So these are the orders that we have and the amount that is spent, right? So this is a data frame. So we are creating the temporary views for both customers and orders. We are writing a Spark SQL where we are joining the customer ID with the customers with the orders, and we are only trying to get the US records here, right? So this is a query that we have. What we are trying to do is we showing the results, and then we are actually showing the execution plan for this. Okay, so let me just go ahead and execute this. Let's execute this here. So code is getting executed. So let's just give it a few seconds. All right. Okay. So we do have the results here. So we have the total for the US clients, US customers. This is the output that we have, but we are more interested in the plan, right? So the logical plan that the Catalyst optimizer has used. Now look very closely, right? The first thing that we have join, we have filter, correct? So if you look at here, right? So we have a join, we have filter. So join actually we have put join first and then we have put filter. But look at how the logical plan is. The logic plan is like first we will do the filter and then we will do the join. So that is the optimized version. So even though we said like we are joining and then there's a join first and then there's a country the filter, but what is happening in the catalyst optimizer is that the filter is applied first, so only the required results has been taken, and then the join is happening, right? So again, that is a logical plan. So once the logical plan is done, right? So it will analyze the logical plan and come up with the right or optimized version of this join, right? So you can see the details like, the filter is applied on the country code, which is 9. The inner join, the joins are all applied, and then the optimized logical plan is here, and then it gets converted into a physical plan. It's basically whatever, we have the broadcast join, we applied the filter and all those things. So all these things is taken care by the capital optimizer, and then finally we will get the output, right? So this is how the catalyst optimizer works. So even if we come up with a query which is not really optimized, the catalyst optimizer will look at the query, it will scan the query, it will convert it into logical plan, it will analyze it, it will ensure that it will use the right rules to kind of uh, optimize that query, convert that logical plan into physical plan, and then execute it. That way, we will have a better version of what we have written. So that is the Spark's internal capability that we have. So this is an important question, as I mentioned. So I hope this was clear to you guys, and I'll see you guys again in my next class.